which means the three quantities described by the three equations, or we simply look at these three equations. And here, for this example, we don't need to calculate this one, so we only have three equations here. Okay, among the three equations, you can see on one side it's so messy in terms of the symbols. We have so many elastic constants. And on the other side, we have three stresses, three stress components, and we have three strain components. So here, by looking at these equations, I need you to clarify what information are given and what information we're looking for. So in general, looking at this equation, you should tell yourself there's two types of the information here. One is about the material properties. The other one is about the stress and the strain. Material properties usually are given. For example, here for this example, they are given. So that means all the material properties here in this equation, you should treat them as known constants. Don't be bothered by those kind of messy equations. Okay. So in this way, in total, we have three equations. Then we have six variables, three stress components, and three strain components. 6 variables, 3 equations. That means you need to identify 3 information to fix the stress or strain to solve for the other 3. Okay, so that is the key of thinking this one. So we keep this in mind and then look at your can I work it like this? Because later I don't want to rewrite these equations. And so you have your handouts, so why not I just turn off? So now with the 3 equations, then we start from here. So that is our starting point. And now we look at what kind of the 3 information we are given by the problem statement. So we can read these problems. The first one is this composite material is constrained against the deformation in the z direction. Z direction is not allowed to deform. What that means? So z direction is equal to 0. So that means the strain in z direction equal to 0. Okay, and elongation in the x direction is elongation. That means delta x equal to 0.035. So that means strain in the x direction will be delta x divided by the dimension. Dimension in x, let me call it Lx. Okay. So that would be equal to 0.035 millimeters divided by the dimension in the x direction. Oh, here they don't have.
Yeah,
right?
It states on the back when they solve for the strain in the x direction.
Good. Okay. But here, suppose the Lx must be given. Lx is 40 millimeters. Okay, I think that one is from the problem 21. Yeah, sorry, and so that should be given here, okay? So Lx, the dimension in x must be 40, so keep that in mind. So this one will be equal to 0.875 times 10 to the minus 6. And then we fixed this one. We have this one. Then we need one more. And look at this one. This one we apply, basically the loading is applied in the x direction. So here x is our axial directions. Okay, axial loading is in the x directions. And then we constrain in the z. And did he say anything about y? No. So that implies y, the material in the y direction is free to deform, right? Free to deform, what that means? That means the stress in y direction is equal to 0. Sounds good. Okay, so that means here we have 3 pieces of information, and then we can put into here, so let me label it. So z equal to 0, so this one equal to 0. And x equal to this one, so that is 875 times 10 to the minus 6. And then y equal to 0, so this one equal to 0. Okay, and now we look at the parameters. We are given Ex equal to 50 GPa. So we have Ex, so let me circle the information we have. So we have Ex here. Oh. And then we have the EY. EY is 15.2. So here we have EY. So EY given. And here we are given EZ equal to 15.2. So EZ, this one. And now we are given the XZ. This one is 0.254 XZ. So where is XZ? Where is XZ? This one here, right? So we have this one. And then we can utilize the properties, this one. We can utilize that property and to calculate this number. Can you see it? Okay, so I leave that for your calculations, okay? And then we are given xy equal to 0.254. So xy, new xy, where is new xy? Here. And then again, utilize the properties, we can calculate xy ex. We can use that, we can calculate y-x. So that means new y-x, we can calculate this term by that relation. And finally, we have new zy equal to 0.428. New zy is
middle right. Middle one. No, middle equation, like the second one down. Yeah.
Oh, okay. So what happened here? But anyhow, okay. So with that one ready, then we can calculate this one, right? But this one is not important. So basically here we should be able to fix all the material properties we needed for the calculations. So the remaining is this. We have 3 information, 3 equations. So here when to solve for here, we highlight is the variables here. Sigma x, we want to calculate this one, and we want to calculate sigma z, and then we calculate sigma y, this one. Okay, so basically here I highlighted the remaining 3 variables we can solve from this equation. So the detail, just go to the little bit careful the detailed calculation in this hand. Are we okay? Okay, and this one is similar to the homework, one of the homework field boundaries.